So we're back to sketching graphs here, and what we're looking at is a translation along the x-axis, or a horizontal translation. This is indicated in the rule by the bit inside the bracket. So that will be a positive or a negative translation on the horizontal axis there. So a horizontal translation. Let's have a look at this in an example. So y is equal to sine outside of theta minus 90 degrees, and we want to draw the graph between theta equal to 0 degrees and 360 degrees. So that's our domain. Let's start off by finding the amplitude, the period, and we'll then look at the translation. So as per usual, the amplitude here is in front of the sine, which is 1, which means y is between -1 and +1. So there's no y translation at this stage. The period of this graph is 2 pi on n. Now what's my n value? You can see here my n value is 2, so the period of this graph is pi. Where does this graph start? Well, if there wasn't a translation on the theta axis, so because we're looking at theta and y here, then it would be starting at 0 because it's an upright sine graph. But because we've now got this translation, and theta minus 90, if you let it equal 0, so theta is equal to 90. That is my starting point, theta equal to 90 degrees. And what we need to think about here is that although my period is pi, which in degrees is 180 degrees, therefore I'm going to go from 90 degrees, and the whole period is 180, so it brings me up to 270 degrees. That's one full cycle of my graph. So let's do that exactly the same way as what we were drawing graphs before. And so here you can see that I'm going from 1, that's the top of my graph, to the bottom, which is here, which is -1, okay? And then I'm going from 90, which is there, to 270, which is there. Now that box forms one full cycle of my graph. So let's draw our graph in there. So we know that sine starts in the at the beginning there in the middle, goes through the middle again, ends there. In the middle of the first section it goes up, and in the middle of the second section it goes down. So my graph is looking something like that. And yours is going to look a bit nicer than mine. That is one full cycle. But of course, I wanted my graph between 0 and 360 degrees. So I now need to extend it backwards and forwards. So if I think about it going backwards, I've got another 90 degrees. If you have a look at the graph there, 90 is half a cycle. So it's going to go down there and up there. And so there's my graph that way. And of course I've got to go up to this point here. And so therefore I go up again. And that is my graph of y equal to sine of 2 outside of theta minus 90 degrees. So not overly difficult. I think the best way though is to start by drawing one cycle and then extending it backwards and forwards if you can. Let's have a look at the next one. We're going to start exactly the same way by finding the amplitude and the period. But what I need to do here, remember this is one of them where it's 2t inside the bracket and I only ever want to deal with t. So let's take that out, and so y is equal to cos. And I'm going to take that 2 out the front, and that becomes t minus pi on 6. That is much better because that gives us the appropriate information. That now makes the amplitude 1, so it hasn't changed the amplitude at all. So y is between -1 and 1 still. My period in this case is, now we're in radians, so period is 2 pi on n, and in this case n is 2. In the other format it was more difficult to actually work that out. So my period is pi. And where do I start? So my starting point, well, remember, let the bit inside the bracket equal 0. So I'm going to start at t equal to pi on 6. So that's a little bit of information now to help me set up the graph. Just remember, I'm starting at pi on 6 and I'm going for 1 full pi. Now that is the same thing as 6 pi on 6 if I use a common denominator there. So if I go for 1 full cycle, I'll end up at 7 pi on 6. Now my domain for this graph is only really between 0 and 2 pi on 3. What is 2 pi on 3 with a denominator of 6? Well, times by 2 times by 2, so 4 pi on 6. So really I'm not going to be drawing a full graph here, but let's start off with trying to get some information into this. And I know that my amplitude is 1, so let's go across that way. Remember, if you're doing these, it's very light with a pencil because it really isn't part of the graph. It's just guidelines to help you draw. And where are we starting here? We're starting at pi on 6 in terms of the beginning of our cycle, and we go to 7 pi on 6. Now you can see there that that is off our graph, and because we're only going as far as 2 pi on 3. So what I might do here is think about half of my graph. So half a cycle would be 3 pi on 6, which would bring me to 4 pi on 6 if I'm going to draw half. So 4 pi on 6 is 2 pi on 3, which is about there. But I only want half of my graph, half of my cosine graph. So what do we know about a cosine graph? It starts up there, and halfway through it drops to the bottom. In between that, it goes through the middle there. Now, what do we know over this side? We're going to go through the middle there, but I'm not going that far. So, my graph that I'm interested in is only that part between pi on 3 and 2 pi on 3. Now remember, our domain started from 0, so I do have to extend this graph backwards. Now how far back? Well, if you have a look at this over here, my halfway point is bigger than pi on 3, which means that it's going to be over here somewhere. So my graph goes like that. Okay, it goes like that because it's then going to go through that point there. So that's a really difficult one. It does get you to think about lots of things that are actually happening in that equation.